There are different formats used for equations of lines. What we're going to look at are the three formats given in Chapter 1 of your text. The first format is the general linear equation. So when an equation is written in the form of ax plus by equals c, where a, b, and c are real numbers, then we call this a linear equation, and it forms the graph of a straight line. Notice that x and y are only raised to the first power, so we say that these are first order in x and y, and a, b, and c are just numbers. So for example, we could have an equation written as 4x plus 2y equals 9, or a second example would be 6x minus 3y equals 12. And we'll use these examples in all three equations just so we have consistency and you can follow the equations in different formats. Now, when a model is written in what's called slope-intercept form, then it's written where y equals the slope times x plus b, where b is the y-intercept. So this is the slope-intercept form of a line. Again, the value of m is the slope of the line, and the value b is the y-intercept. And you will recall that the y-intercept is just where the line crosses the y-axis. It is also the point 0b because the x value is 0 when the line crosses the y-axis at location b. So, for example, we could solve for y to get the linear equations in slope-intercept form. So in the first case, 4x plus 2y equals 9, we would solve that for y by subtracting 4x from both sides. So you'd have 2y equals negative 4x plus 9, and then divide through both sides by 2. And that simplifies to y equals negative 2x plus 4.5, or you could write it as the fraction 9/2. In the other equation, you solve by beginning with subtracting 6x from both sides. So you'd have negative 3y equals negative 6x plus 12. Then divide through by negative 3. So you end up with the equation y equals 2x minus 4. It is very easy to graph lines when they're written in slope-intercept form. First, you know one of the points on the line is x equal to 0 and y equal to the intercept, and that would be the number sitting by itself, not the one multiplied by x. All you have to do is find one other point on the line, and there's multiple ways that you could do that. For example, we know that 0 and 4.5 is one of the points on this first line because the y-intercept is 4.5. Then we just choose another value for x, for example 2, plug that into the equation, and solve. Similarly, we know that 0, negative 4 is one of the points on the line, and then again we can use the value x equal to 2 and solve to get another point. So in this case, all we're doing is taking our equation and we're plugging in the value x equal to 2 right here, then multiplying and doing all the arithmetic. So we end up with 2 for the x value and 1/2 for the y value. In the other equation, again, we're going to plug the x equal to 2 in where the x is. So 2 times 2 is 4, and 4 minus 4 would be 0. So this gives us the point 2, 0. Now thinking about this, if x is 2 and y is 0, then the line is crossing the horizontal or the x-axis. We actually call this the x-intercept of the line. Now, one other model is called the point-slope form of the line. And usually what you're doing here is using this format to solve and get the equation into the slope-intercept form. So if you're given the slope and one point on the line, you can use this model. Or if you're given two different points and asked to find the equation of the line, you can use this model. So you need a slope, which you can get either by it being given or by given 2 points, finding the slope between the 2 points. And then you use one of those points in this model. And it doesn't matter which one you choose. So remember, we know that 2 of the points on the first line are the points 2, 1/2 and 0, 4.5. On the second line, we know 2 points on the line, but let's go ahead and use the slope of 2, which we're given. So in the first case, we will have to find the slope. In the second case, it's given. So for the first one, let's find the slope. Well, how do you find the slope? Well, you take the difference in the y-coordinates, so 4.5 minus 1/2 will give you 4, and then difference in the x-coordinates in the same order. So 0 minus 2 will be -2, and then 4 divided by -2 is -2. Now in the right-hand side, you were already told that the slope was 2, so we don't have to solve for it. Next, what we'll do is use the equation and plug the values in. So you take the variable y minus the y-coordinate from the first point, which would be 1/2 in this case, equals the slope, that was -2 from right here, times the variable x minus the x-coordinate of that same point, so that would be 2. Then you distribute the -2, so you get -2x plus 4, and then you're going to add 1/2 to both sides. So you end up with the equation y equals -2x plus 4.5. In the other case, you can use y minus 0, right? So that's the y-coordinate, so y minus the y value, times the slope, which we were told was 2, times x minus the x-coordinate, or 2. Again, y minus 0 is y, and then distribute the 2, and you get 2x minus 4. If we go to the document here, what we can do is look and see if we've got the y-intercept, okay, which is going to be the point 0, 4.5, right? The y-intercept is the 4.5. And then we find one other point, 2 and 1/2. The blue line is what the equation of the line is going to be. If we click on the equation button, it gives us the equation of that line. Okay, we can also talk about the slope, okay, and how it is calculated. Okay, so I'll take that off. But this is the equation of the line that we found. Now let's go back to the other points, okay, and look at those. What were the other 2 points? 0, -4, and 2, 0. So 0, -4, and 2, 0. Okay, so notice now the line is increasing or has a positive slope as we move left to right, whereas in the first example it had a negative slope. If we click on equation, we can see the equation as y equals 2x minus 4. Also, these graphs are given here for your convenience. So let me pull those down a little bit. So these are the two graphs that we just worked with in these examples. Now the last two things to keep in mind are horizontal and vertical lines. A horizontal line, okay, is going to have the formula y equals a number, like y equals 4. In that case, the line goes side to side in a graph. So let's look at an example of that. In this case, let's just go to integer values to make it easy. Notice the y value is going to be 3 no matter where you are on this line, but the x value can change. So if we say y equals 3, that's going to give us a horizontal line. In this case, the slope, okay, m equals 0. And if you think about the equation, you could say y equals 0 times x plus 4. And that would be what graph? Let's go back and make these 4. So this is the line that we're talking about in terms of that equation. And then, of course, 0 times x just simplifies. What about a vertical line? Well, a vertical line is going to be defined by where x is. So x is 3, for example. Now, in this case, what is the slope? Well, we say that it is undefined. Okay? So if x equals 3, let's look at that graph. Okay. Notice the x-coordinate is 3 no matter where I move to points on the line, but the y value can change. Now in this case, if we tried to subtract the two y values, we would get like 6 minus negative 2, so we would get 8 in the numerator of our slope formula. Remember, the slope formula is the difference in the y's. But when you subtract the two x values for the denominator, you would get 0. And division by 0 is undefined. Therefore, for a vertical line, we say that the slope is undefined. And we really can't write it in terms of y equals some number times x plus a constant. Okay, we have to write it in the form x equals a number. So those are the different models for equations of lines that you may come across under different circumstances.